Welcome. As PTP has become the backbone of ST2110 synchronization, many broadcasters have experienced unexpected PTP behavior, reference mismatches, and unplanned grandmaster changeovers that disrupt operations. Glad you are here. If any of that resonates with you, welcome to how to properly implement a PTP solution in your station. And this is brought to you by Heartland and Leader. So we've got Joe Turbo at Heartland Video Systems and Leader in the house here. So stay with us because during the next hour, Steve Holmes is going to help you find out how and why PTP reference mismatches occur, what triggers unnecessarily occur and make a grandmaster switch happen, how to recognize early warning signs of a PTP problem. Steve has got you. Over to you, Steve. How are you doing?
I'm doing great, Cindy. How are you doing? I feel like it's a Monday morning. How's everybody doing? Uh, Hope you have a great time here. We will take some questions at the end. We will also have you submit all of your questions that are submitted. We will answer all of them. We probably will not have time for more than just a couple at the end. There's a lot of information packed in this hour. So we will honestly answer every single one of them, though. So, Cindy, ready?
Ready to roll. Put your questions in the chat. And like Steve said, we'll circle back to you offline if we don't get you live during today's session. Steve, let's get into it.
Definitely, Cindy. So, as Cindy said, there's a lot of different things going on in walking from SDI into PTP. So let's take a look at a lot of what goes on. So for everybody that's in the business, everybody knows we've got an SDI SPG. It provides all of the signals for our black burst tri-level sync needs, test patterns, and everything for our existing SDI plant. But then when we want to branch out and get into SMPTE 2110, we're going to need to provide PTP out of an SPG now. Now you can add just a second SPG and tag it to your first SPG. You can use black. There's several ways to do this, but this enters some issues. The first of which, black burst is only roughly about a 1 microsecond timing system. Black burst, or excuse me, PTP, i.e. GPS, because PTP carries the same quality as GPS, is a 100 nanosecond or better reference system. But if you're locking it to black burst, it's only going to be a 1 microsecond system. The other issue is if something happens to that black burst link, you will now have an issue where the two systems are no longer in sync with each other. And most of us at one time or another have seen this very issue where we've got unsynced sources and they're just flying by when we try to look at a timing display. It's not really the best way to do this. So we want to stay away from having sync wars. We do not want them. It can take you off air very quickly. So we can put in a PTP generator and sync my SDI off of that PTP and then run things. But we run into the same exact conditions. Now, the beautiful thing here is since it is linked via PTP, it will have the same exact quality that the PTP generator has from GPS, but we still have that link between the two. And we can still have some of the same issues that if that link gets broken, we're going to run all my SDI plant free running while my IP 2110 system is dead synced. So we will take a look at this in a little more detail. There are a lot of challenges and in working with this, and some people want or have people come in that have done PTP for years and years and years, because PTP is not new. It's been around longer than 2110 has by many years, but it's always been from a data center or a telecom use. And what we do in 2110 is a little different in how we need to use it. So in looking at this stuff, we need to look at how things work, because bursty packets versus deterministic flows can really cause issues. One packet out of place can cause that picture on the left, because one packet in 1080 video is a quarter line of video. And if you drop it and that drop gets through the system, you will get either this picture, or most likely it'll actually go black from where the error hit to the bottom of the picture. It can be pretty nasty. The other unique thing from the telco type world is it's not uncommon for them to have two grandmasters here and feed one side of our system from one grandmaster and feed the other side of the system to the other from the other grandmaster. The problem is that endpoints don't have to obey the BMCA, the best master clock algorithm, that chooses which generator you're going to lock to. The other issue is there can be fractional phase difference between these two, just because we're dealing with packets and we're generally going through several switches to get there, especially in a leaf spline system. You're going to be 2 or 3 hops to get PTP to the end source. And those hops can be forward or backwards. And so you're going to be there by the width of a packet. Now, most of the time, PTP does its darndest to take care of that and null that network delay out, but it's not absolute perfect. So we can have several things happen here, and we call it the split brain syndrome. So you could have a main PTP grandmaster go out. Yes, I still have PTP coming down this side feeding the receiver, as long as the receiver can walk over to the backup PTP system. But if you happen to have a catastrophic failure where now you lose your blue network, so our red and blue networks, guess what? I have no way to get PTP to this receiver, even though I have a valid data path on my red network, but it has no PTP in it. So one of the things that we do is provide a PTP distribution layer that is above the splines. And this distribution layer only deals with PTP, but it lets the two grandmasters talk to each other and provide PTP down both paths from a single generator. That way, the phase and the clock ID coming in off of each side is exactly the same. And you actually get one level higher of absolute protection, because now this generator can go across, come down, and still provide PTP to that endpoint, as well as all the data working. So it is really, really important that we think about this PTP distribution layer. So, and the nice thing about it, as your system grows, all you've got is this distribution layer, and you just keep extending that distribution layer to the new spines that come in. You got to do some thinking here of how I'm going to get distribution over to another side. And then if you take it from either a leaf back up, or if you take it from the spines, you increase hops on one section of your network, and you don't have as many hops on another section of your network. So it's not the best way to do things. So in looking at this, the priority fields in PTP are quite often misunderstood, and how PTP uses the priorities to ensure that the best oscillator always wins, or the best grandmaster always wins. So a key here is looking at what happens when you have the ability with your 2110 network to have a link between the two grandmasters that is above actually your absolute 2110 network. So no data goes across the link, but PTP can go across that link. When the generators start up, they go into listen mode, and they look for announce messages. And the SPGs are putting out announce messages saying who they are, what their domain is, what their priority one is, what their clock class is, and what their priority two is, and sending that data back and forth. The BMCA will take over and say, yep, you're going to be the grandmaster, you go passive. And this unit will be running, but it will be passive as far as the PTP is concerned. And the grandmaster over on the right-hand side here will take over, because his priority two is lower than his priority two. Priority one has to be the same. If you don't make priority one the same, as you'll see in a slide, you'll never switch on a GPS failure. If you have a GPS failure, this clock will still maintain itself being the grandmaster. This side can never walk in until you have an absence, 100% absence of PTP. So if I have something happen to my GPS, this unit will go from a clock class 6 to a clock class 7, which means it's in holdover. It's still got the right phase. It's still running, but it's running on the internal oven-controlled crystal, but it's not locked to GPS. This unit is still locked to GPS, and since the clock class sits above priority 2, it overrides priority 2, and this second unit here, your second grandmaster, will just walk in as being the grandmaster. It doesn't have to wait for PTP to go away. PTP was still running even when it was clock class 7. But as soon as this unit sees that announce message, it says, hey, I'm better clock class than you are. You go passive. I'm going to walk in and be the grandmaster. And it's a software walk. And it's hitless. And it just walks over to the other unit and keeps going. The only thing that changes is the grandmaster ID. So the grandmaster ID will go from this unit on the right to the unit on the left. And we will keep going. So the domains of the system, if you look on this, this was domain 40, this was domain 40. Domains are like a VLAN. It's just a way to separate traffic. And you can pick any number that you want, as long as you really stay away from two different domains. You want to stay away from domain 0, and you want to stay away from domain 127. 127 is the default. So when a device is placed on your network, it starts up. If it happens to have the ability to generate PTP, it's going to start up and it's going to put itself on in 127. And if it's priority 1 and priority 2 think they're better than your system, they can actually take over, and it can be really nasty. Domain 0 you really want to stay away from, because it's used for AES 67 and Dante and audio. And it's just best to stay away from those two numbers. Pick any number you want, and that's your domain. I use domain 44 in my office. I just grabbed it out of the sky and used it. So we need to think about things that happen in video. I mean, we're dealing with phase, we're dealing with pixels. In audio, they're dealing with much larger gaps that they can deal with, that we cannot deal with. It's one of the reasons we have a red and a blue network, is because we cannot survive a single packet drop. And if you have an error, IP switches drop the errored packets. I have a whole nother segment that I go through on network and within a -7 network, why we do that. But so here's kind of a network that's got a PTP distribution layer, takes the PTP down to the leaves, or down to the spines take it down to the leaves. Some people don't want to waste 100 gig port for PTP, so they will go down to a set of leaves and have the leaves back it back up, which is fine. It works exactly the same and has no issues at all. So you just want to make sure your domain is consistent across your system. The other unique thing is you want a system that is robust, that if a fault happens, everybody stays in sync. And the absolute best way to do that is having a SPG that has a single oven controlled crystal, and the GPS locks that oscillator. That oscillator now drives your baseband and tri-level sync. It drives your test patterns. It drives your AES EBU stuff. It drives your 2110 test patterns, and can be a PTP generator for your system. That way, if you were to lose GPS, everything still locks to that internal oven controlled system. And we have what we call a stay in sync system. Since everybody's locked on that one oscillator, yes, it will very, very slowly drift from what the GPS is. But when GPS comes back, our slow sync will take the system back very slowly and put it right back on what the GPS phase is, and bring that phase back in very slowly. And it locks everything together. And there's not a device down below this SPG that will ever see that the phase actually ever even moved. or you went off of your GPS lock. So we need to look at this and think about how we've kind of tied everything together and look at all of this. So when we have our system put together, we've got a grandmaster up here. It's locked to GPS. I have my second grandmaster in waiting, locked to GPS. They're both feeding the SDI and baseband signals to the ECO, the emergency changeover. And then PTP is doing its thing out in the network. Now, this unit is online feeding PTP. This unit's also online through the ECO feeding the network. This unit is passive for what's going out to the PTP, and it's feeding the signals into the ECO, but the ECO is using the other side. We have a cable that links these two for the failover so that both systems feed the ECO, but also provide for something else. It has a link from the ECO back to the grandmaster and has a link from the ECO back to the backup unit. And the whole reason for that link is when things happen. So if I have a error that happens and I lose GPS up here, I'm still going to be feeding this ECO from that generator because nothing has happened to his black or test patterns. So the ECO sees absolutely nothing. So this top generator is still feeding all of your baseband to your system, but the bottom generator is now online for all of the PTP sources. And this can get into a maintenance nightmare in that you know that your grandmaster has walked over. So you go to tear into this unit to try to figure out what in the heck happened here. And you yank it down and you'll cause a hard switch on your ECO on all of your black. Because if I downpower this unit completely, the ECO won't know to switch to this until it sees that the signal is gone. And that is a disruption in the service. What we want to have happen is not this oops where we've got the system running half one way and half another way, is we want the system to hook up so that we cause the ECO to switch, and it would be a soft switch on the ECO over so that now both sides are running off of the same system. And the same thing would happen if you lost blackburst. I now lose blackburst. Yes, I will switch my baseband signals over, but I'm still feeding PTP off the top grandmaster. This is not something you want to have happen in your network. So that same interlink cable will turn around and tell this generator to change its priorities so that the generator on the bottom says link changeover, and we can set up a BMCA link to the changeover and cause this grandmaster on top to change its priority so that the second grandmaster takes over. And that is a soft switch on the PTP side. And it just walks over. And again, we have everybody running the same, whether it is on the grandmaster as the system should be, or when we have a fault, everything switches together. The second piece is, in most cases, PTP is auto recovery. So if a fault goes away, PTP corrects itself. And it would turn around and walk from this grandmaster back to this grandmaster, and this guy would become passive again. This guy would become active. But faults may come and go. We've had a lot of issues with GPS jamming from truck drivers, where truck drivers have these little itty bitty boxes that jam the GPS in their trucks, so their boss can't track them. But if they get close enough to your GPS system, they can actually cause havoc in your GPS system and cause it to toggle back and forth, back and forth. Most of us would like the PTP to behave how ECOs have always behaved. And that is, once the ECO switches, it stays switched, even if the signal returns, until the engineer goes in, verifies everything is correct, and then the engineer turns around and brings everything back. And we have a manual changeover reset, one button that's in the SPG, and that will take and recover your system completely and bring your system back to normal after you've verified that both PTP and your black signals are where they should be, and bring the system back to normal operation. So this is really, really handy to have. And we make it so, if you want, and it's up to the user, to have the system only switch once on their 2110, so it switches exactly the same as ECO does, or you can leave it on auto recovery and have it come back, but then your ECO is still running on the backup, even though 2110 came back. And now you've got half your system on one, half your system on the other, and it's a maintenance nightmare and a potential issue if something weird was to happen between these two. So, like I said, telco systems utilize the self-healing methodology. Data centers do, but we're dealing with more than just GPS. We're dealing with all those test patterns, with all the bi-level and tri-level. Even if you think you're going to be 100% 2110 rebuild system, you're going to have black burst and tri-level in there somewhere. It always happens. Different things come up where you've got to have this. And it's also your timing reference to know that you are in sync with where everything should be in avoiding things. So, as I've said, the changeovers require you to manually reset them so that you can verify that there's no faults. All signals are present on the primary side, and turn around and bring it back manually. And you can push the button, enable the button, push the button, bring the system back. We do the same thing here. Enable BMCA only once in the SPG. That way, it's going to act exactly as the ECO did and only walk itself over one time, so that you can go and investigate, why did it walk? Or was it the SPG failure on black or test signals that caused the PTP to come over with it so that now you can do maintenance on that system. Validation and testing is so important. A lot of people test things by just pulling the PTP out of the generator. That does not test the problem when you have a loss of GPS or degraded GPS in your clock class switches. So you need to be able to verify things even on a clock class switch when PTP is still there, but it's not the quality that the passive unit is so that it switches. The other thing is one of the SX units that Leader Fabrics has is the tag. The tag has the ability to have a fiber input. It can be very helpful in looking at your network when you're putting it all together. We can look at the transmission mode, we can look at sources, we can look at lock and tell all the IDs, what domain, what QoS is running. And when you have a large network and you're using boundary clocks, you need to make sure that all the boundary clocks are putting out the priorities, the domains, the priority 1, 2 settings that you expect them to do, and not have a wrong grandmaster ID and having the priority 1, in this case, wrong. And this was actually a real world case where one spine had the wrong priority 1. And the system was running, but it was running intermittent, because anytime a path went through this particular spine, it didn't work. It would fail. But if it used the other 2 or the other 3, the paths worked just fine. But if it went on that one, it would fall out of sync because it was running on the internal oscillator of the spine, which was not in phase perfectly with where PTP was. And by walking through and doing all this testing, it was able to be found that the wrong grandmaster ID. And unfortunately, this system went into service this way because they didn't fully test everything. The other unique thing is verifying PTP timing. Now, PTP and Blackburst have the same exact starting point. Both of them start at line 0, pixel 0. And we need to verify that my PTP is starting and my PTP and Blackburst are acting as they should, and they're perfectly in time with each other. The other unique thing is there is a RTP timestamp in the video leg of 2110 in the -20 that RTP is time stamped when the frame is made. And because of the way 2110 works, only the green here gets put in the -20 video flow. So we need to verify that the starting point right here of the video is exactly the length of what the SDI vertical interval would be. So this is a 1080i feed. So this vertical interval is 21 lines in length. And in this case, my RTP timestamp came out at 20 lines. And what I have found is pretty much as long as your 21 lines plus or minus 2 you're within what the buffers will withstand within the 2110 system. It's best if you could have this thing on exactly 21 lines, but 20 will actually work just fine. But you want to make sure that if you're 1080p, you should be 42 lines out. If you're UHD, you would be 42 lines out because it's made up of a bunch of 1080p's underneath the hood. So we're referencing this back against PTP and then checking against that RTP timestamp that's in the header of every single video packet. So all of one frame has the same RTP stamp. That RTP stamp is the time when the very first packet is created. There is now one other measurement that needs to be made. And this one is called FPT, first packet time. This is the first packet that is read into the processing buffer. Technically, it should be just a little bit more horizontally shifted. But again, since it's at the same time as when the video was created, in this case, this one is exactly 21 lines out, so that I know that my video that is being processed is going to be processed and perfectly in time with anything else that I have in my house. All of my anything that I have for doing graphics or cuts between an SDI source, another 2110 source, or cuts between 2110 sources, the video will be perfectly aligned, and the switcher and everybody else will not have any issues in going through any of this. So there is three pieces that we want to make sure are in time with each other. You need to make sure the PTP and black are perfectly in time with each other, PTP and the RTP timestamp, and PTP and first packet time. Now, the most critical is the PTP in black and the PTP and first packet time. The RTP timestamp is used by a lot of equipment to find first packet time. Some systems will just find first packet time and they won't look at RTP timestamps, but it's all in how the designer of that receiver designed that receiver either to use RTP or not use RTP. So there's systems that do not check RTP time in systems. They only check where black is and first packet time. They don't check black RTP time and first packet time. And I have seen systems fail when they don't have the RTP timestamp because they're using the RTP to find the first packet time. I hope this video or this session opened up some thoughts for you and was very entertaining, was informative for you. We want to thank Heartland for putting this together, and we've got time to answer a couple of questions before we need to jaunt off to the rest of our real life here, our real work. So, Cindy, were there
Hey,
a
Steve.
couple of questions that people had?
Yes, we've got some questions, and some of them we are not going to get to all of them, but we will circle back to you. One of them was, can you talk more about how slow sync works and what to do if my system doesn't have that?
Well, so slow sync deals with if you lose GPS. So GPS is perfect timing, and the SPG is running on its oven controlled crystal, which is a 1 ppm or greater crystal. And yes, it will very, very slowly sync away or phase away from the GPS signal. What slow sync does not, when GPS is put back on, it will not slam itself right back to be in phase with GPS. It will bring itself back slowly and slow enough that nothing in your system, you won't have any uh, video hits, you won't have any color shift, you won't have any audio whoa or flutter or phase change. It just slowly brings the system back into absolute phase with the GPS slowly. And so you don't have any hits when you reapply your lock signal, be it GPS, PTP, black, whatever it is, it'll slowly come back into sync.
Steve, you talked about GPS spoofing, and is there anything that a broadcaster or facility can do to protect against that? Or do you have any thoughts about that whole spoofing and how to avoid?
Um, it's kind of hard. The truck thing is not too hard to do. Our new antenna that we sell has some stuff in it to help prevent that type of spoofing, in that it has a big ground plane at the bottom of the antenna so that it has almost zero reception from the ground going up to the antenna. It only receives signal from the sky coming down to the antenna. So that ground plane in the bottom being a reflector, which helps reception, but it won't let things from the ground come up, and it helps on spoofing with that. But it's something that is getting harder and harder to prevent.
Got you. That's really helpful. Thank you for that. Glad to know about the antenna. Super interesting. So I have a question here from someone that says, right now we're really just using Blackburst and Tri-Level. What's a good way to get started using PTP? We know we're going to have to do it sooner or later. I want to say, if you just mention in the chat that Fallon will send you the leader PTP guide, and then Steve, over to you to speak to that.
Yeah, the best way to do this is get yourself a SPG that has PTP in it, has all your black in it, and build yourself a sandbox that you can start learning all of this in the sandbox, rather than try to install this stuff and learn it on your online system that you will at some point take down by doing something that you shouldn't have done. Uh, it's one of the best ways to learn this stuff. We have many, many, many YouTube videos on the Leader YouTube channel. I've got them on PTP. I've got them on everything you can think of. My partner in the UK and I do a lot of them together, and I've got them on basic PTP, got them on almost anything you can think of, all the way through 12G SDI testing and everything in between.
Yeah, we'll pop the Fallon, if you've got the YouTube channel, pop the link in the chat. Otherwise, we'll follow up with y'all afterward and give you the link to that. So, Steve, you said don't use domain 127 and you use domain 44. And I just want to say that's Lewis Hamilton's number in F1. So, 44. I don't know if that ties in or what, but there you go. So, I have another
uh,
question. Which leader gear has fiber in it? I think you mentioned something about fiber earlier.
um, I'm not sure exactly what they mean by fiber in it.
I don't know if they mean like an input
So
output
our
or.
PTP generators can output. They have the fiber sockets in them, and you can put an RJ45 unit in there, a 1 gig, 10 gig in there, And so they will provide the PTP over on the SFP, whichever way you want that output to go. It also has the ability for 2110 test patterns on either 10 gig or 25 gig out. So those are options that you can have. As soon as you get PTP, it's got the SFP ports. It's got two independent ports. Without making this a sales presentation here, this was meant to be a technical presentation. I don't want to get too salesy. I'm not a sales guy.
You're an information sharer. We love that
Yes,
about you, Steve.
yes.
I like that. And we've got a good comment here that the defaults maybe should be 42. And I think that person's not wrong. Everything should be 42, right?
Yeah.
Oh my
Well,
gosh.
the defaults, yeah, you got to be careful because anytime anything defaults, everybody puts it on there, and then you can't use that number. You got to use a different number because it's the default of everything.
It's so
When they
funny.
were doing the testing of 2110 and PTP in Texas for the dirty hands stuff, when vendors were bringing in their equipment and tuning it and stuff, the network was taken over multiple times by using 127. Everything they started up, they left it on 127. People would drop in equipment, the equipment would take over from the network. And this is all comes back from real world instances where in the dirty hands testing, they actually had to change their domain to some other number because equipment was coming in. We even had equipment come in that put in invalid numbers that says, I'm the the master clock in Boulder, Colorado that the world runs off of. That's my numbers, and it's I am it, and no one else can be anything. And it's like, you guys realize those are wrong, and they go, yeah, we know, but it took the network over, and they couldn't stop it.
That's so good. That's so good.
So
All right. For the
anyway,
rest of your questions, we're going to circle back to you offline. We'll take care of you. Joe from Heartland Video, and Mango's here because he wants to be on this webinar too. Joe from Joe Turbo from Heartland Video is going to get back to you with everything you need. Come see him. Go see him at NAB. His email is in the chat here, and you can book a meeting with Joe and the other Heartland Video team members at NAB. Also, if you want to see the SPG, ECO, all the slow sync, all the cool things that Steve was talking about here, go see him. Go see Tom O'Neill on the leader booth, which we've got the stand number in the chat as well. And thank you, thank you. Any final words, Tom or Steve? Tom, do you want to
well,
say something?
I just want to let everybody know that we did record this. We will have a recording of this presentation. Heartland will have that on their system. We will most likely have a copy of it on the leader system as well. So, Tom?
Yes, sir. If anybody wants to get in touch with me, I can make sure that anything that you need can be made available to you. So just send me an email and we'll take care of that.
Tom's email is in the chat. We got you.
And we just want to thank everybody for your time this morning. And I hope, like I said, this was informative and you got some good information out of it. Other questions, please just let us know. Respond back, and Heartland can take in your information, get it to us, and we'll put the answers together for you.
All right. Thank you, everybody. Have a lovely day.
Take care, everybody.
Bye now.